The production of alumina in our plant is based on the Bayer cycle. So we treat bauxite with caustic soda in order to extract alumina. We need about 2 tons of bauxite in order to produce 1 ton of alumina. And most of the caustic soda is recycled. We consume about 30 kilos of caustic soda per ton of alumina. And this is the raw materials that we use. Also, we need a lot of steam. We need energy in order to increase the temperature of the slurry of bauxite with alumina. We take bauxite in the plant with trucks. In order to decrease the size of the bauxite, we have a line of crushers. The target is to decrease it from 100 millimeter about 100 micrometers, so 1000 times less. We begin with the crushers, and then we have also grinders. We have 2 rod mills and 5 ball mills in order to decrease the size. When we have already decreased the size of the bauxite and we have a lot of surface around, we put together caustic soda and bauxite, and we make a slurry that we are going to feed the next step, which is digestion. Digestion is the heart of the alumina production. In this unit, we put the slurry of caustic soda with bauxite, and we increase the temperature in order to extract alumina from bauxite. Digestion unit consists of 2 lines of autoclaves. Each line has about 20 autoclaves. We increase the temperature slowly from 70 degrees to 255 in its autoclave. And then we keep the slurry in this temperature of 255 degrees for about 30 minutes in order to be sure that we have extracted all alumina from bauxite. Then in order to keep slurry in this temperature, we have increased already the pressure. So the pressure in the autoclaves for the slurry is 40 bar. And then after we have finished with the reaction, we need to cool down this slurry, and we use a series of flash tanks. We recover steam from these flash tanks and we cool down the slurry. This recovered steam is used also to preheat the slurry of bauxite coming into the digestion, so it is optimized thermally. At the end of the digestion, we have dissolved alumina in the caustic soda, and we have also some residues of bauxite, which is mostly iron oxide, as a solids inside. So then we have to give it some time in a settler to settle down all the solids, and on the top we have the liquid. This liquid is mostly the chemical compound inside is sodium aluminate, and it is the pregnant liquor that we are going to use in order to produce alumina. So we take this liquor and we filtrate it very well to be sure that there is no solid inside, and we pump it in the next unit, which is precipitation. In the precipitation unit, we cool down this liquid with some alumina inside, and the target is to crystallize alumina. But alumina is not so easy to crystallize, so we need also a lot of yield, that we put already alumina inside in order to give some surface, and on this surface we build up our crystals. So there is a lot of recirculation of solids of alumina, of hydrated alumina, in the precipitation unit. After the precipitation unit, we separate alumina from liquid. Liquid is caustic soda, and it's going back, recycled back to the digestion unit. And alumina, hydrated alumina, is filtrated, and it is a product that we can wash it. After we wash it very well with water to be sure that there is no soda left, we can have it as a semi-product. It is hydrated alumina, we have it as a semi-product. But also we can feed our calciners in order to produce calcined alumina, which is mostly used for metallurgical production of aluminum.